Okay, look at that slide. The ODE in the Newton's second law, because we know that the Newton's second law is force is equal to the mass times the acceleration. In other words, F is equal to ma. A is equal to the change in velocity divided by the time which it takes to the change in velocity. T is an independent variable in the process of objective motion. So we know that from the definition of ODE that this problem can be solved by ODE. Okay, this is all for me.
Hi, my name is Adinamila. I will present movement in electricity. So here is the explanation of this application, and I will choose solenoid coil and injector to for this application. Okay, so here is more explanation for and the equation. So the first equation is the equation that describes the equivalent electrical circuit of the solenoid. So the second equation is the voltage across the resistor, and the third is voltage across the inductor. So the fourth equation is going to obtain the differential equation that describes the dynamics of the electric current through the solenoid. So the fifth equation is the final equation that analyzes the dynamics of the system. That's all from me. Thank you.
PDE in fluid mechanics. In real-life applications, we can find the concepts in wind tunnel, pumps, fluid powers, and hydraulic presses. The differential equations of fluid flow are based on the principle of conservation of mass, momentum, and energy and are known as the Navier-Stokes equations. Fluid flow. The fluid properties such as density and dynamic viscosity in the conservation equations are not affected by temperature. This assumption allows us to ignore the conservation equation for energy and concentrate only on the conservation equation for mass and momentum.
Next is application of partial differential equation PDE, which is transverse vibration in elastic membranes. In real-life applications, the elastic membrane are widely used in such various engineering devices such as loudspeakers, microphones, membrane valves, and others. Here is the formulation of spectral element model related to transverse vibration in elastic membrane. The equation of motion for transverse vibration of membrane is given by this. Why does is related to PDE is because the formulation given have more than two variables, and also it is second derivative equation of motion.
Application of numerical method is car safety analysis. Numerical analysis is used by automotive makers to create numerical models for car safety simulation, and this action is computer-aided and it determines the best result that represent aspect of a car crash test. The mathematical calculation is very broad in this process. One of the model is called a reduced order model, which involves Lagrangian mechanics, and this process includes Euler-Lagrange equation, which is a second order PDE. And another example is the finite difference model that uses this following formula.